Once again, good morning, everyone, students. I would invite Arun sir to start the session.
Thank you, ma'am. Good morning, everyone.
Good morning, sir.
Good morning. All right. So we were applying Newton's laws to constrain more systems which were constrained to move in particular fashion, right? So just to quickly ask you one question. Let's say this is 2 kg and this is 3 kg. What's the acceleration of the blocks? One is 2 kg, one is 3 kg. What is the acceleration of the blocks? Supporting force is how much? 3g. Opposing is 2g. Students, good morning. Wake up. There's a
One
question in
minute,
front
sir.
of you.
Upwards, sir.
What do you mean upwards?
Velocity, sir. I mean acceleration upwards.
Of which particle?
Third one. Sorry, second one.
What is the
2 kg.
acceleration? What is the acceleration? It's a look and say problem. Choose chapati. You have done this. You have not revised anything?
So I'm telling you G by 3.
How
No,
do you
sir.
do?
G by 5.
G by 5. Right. So it's 3g minus 2g is g by total mass is 5. Now let's say this is 1 kg. What is it? What is the acceleration of the blocks now?
2G by
4. G
How
by
much is
2.
it? G by 2.
G
Right.
by 2.
3 kg and 3 kg.
Acceleration will be 0, no, sir.
No, think about it. There is some force here and there is no force here. If this were vertical, then the acceleration would be 0.
3G.
3g minus nothing by total mass.
1 by 2.
G by 2.
G by
2.
G by 2, right? Why would acceleration be 0? Just because masses are same? No. If this were vertical and the masses are same, then the acceleration would be 0. 3g minus 3g is 0. But it's not vertical, right? It's 6 kg. 6 kg and 3 kg, 30 degrees. Tell me the acceleration now. You've done all these. All you have to do is just look and say,
Sir, is it G by 2?
how do you do? How do you do? You tell me how do you do? This is 3G. What is
Yes.
the
Sir,
force over
minus
here?
G by 3. Minus G by 3.
6.
How much is the force here?
6, sir.
6G is vertically downwards. Component of 6G around the inclined plane. How much is it? 6G sine 30. How much is 6G sine 30?
3.
3.
3G. If this is 3G and this is 3G, will the particles move?
No. 0.
Acceleration is 0.
Yes, sir.
Alright.
Yes, sir.
Now let's say this is 3. Now tell me the acceleration. Students, you haven't done the 10-minute exercise. If you were to do the 10-minute exercise, this would have been very few seconds to చెప్పాల్సింది ఇది.
So minus 1 by 3.
Minus అంటే దేనికి minus? Like it's going upward, downward.
I think downward.
Which particle is going downward?
Mm. Acceleration of 3, sir. 3 kg mass.
Both are 3 kg. It's A and B.
Acceleration of A is 3 by 2, sir.
3 by 2. There's no G there. G factor ఉంటుందా?
3G by 2.
Acceleration of B. If this is 3G by 2, what is the acceleration of B? Okay, let me do it. Because, see, these are very important things. ఎగ్జామ్లో వస్తే ఇక్కడ ఇలా టైం వేస్ట్ అయితే you lose rank. And if you lose rank, whole 2 years of hard work will be gone to dogs. It is 3G downward. Component is 3G by 2. This is 3G downward. So I'll have 3G minus 3G by 2 by 6. Total mass 3 and 3. So which is 3G by 2 by 6, which is G by 4. Is it clear? Is it clear, students?
Yes, sir.
Yes, sir.
Minus G by 4 plus G by 4, G by 6, G by 2 or 3 by 2. So G by 4, which direction? It's in this direction. 3G minus 3G by 2 by total mass. So I've taken this as positive direction. 3G minus 3G by 2 by total mass is 3G by 4, G by 4. So that means I got positive value. So direction which I've taken is correct. In that direction, my particle is moving, accelerating. All right. Okay, now let's go forward, because if I just keep repeating what I've done before, it'll take a lot of time. People, you have to revise, students. Its mass is m, this mass is m. All right. Now I have to find the acceleration of the masses. So I told you, FBD, F is equal to ma, and you get the answer. No matter how complicated the problem is, draw the FBD correctly. So for this one, for the particle on the table, I've got a mass as m, tension is T, or if I say this tension is T, this is T, this is T, this will be 2T, right? Because pulley is massless. T and T, 2T, this is 2T, so this will also be 2T. So this is 2T, and acceleration is, let's say, A naught. 2T is equal to m naught into A naught. For this particle, I've got T, m naught g. What is the acceleration of this particle? If this is A naught, what is the acceleration of this lower hanging block? How much? Sorry?
Sir, 2A naught.
Okay. Ashrita, Gayatri. Is it A naught by 2 or 2 A naught?
A naught by 2, sir.
Huh? Why so? How can you say that?
So I think it could be 2A naught only.
Vignesh, you say 2 A naught?
Yeah, sir.
Okay. Let's see. I move this particle by x. This pulley moves down by x. String slack is by x and x 2x. This particle has to come down by 2x. So this is V naught, 2V naught, A naught, 2A naught. Or if this acceleration of the pulley is A naught, acceleration of this point is 0, acceleration of this point will be ax. Ax plus 0 by 2 is equal to A naught. So Ax is equal to A naught. Either you apply pulley method, pulley equation, or push-pull method, because one end of the string is fixed. Push-pull method or pulley method. You get the same answer, 2A naught. So this is 2A naught. So my FBD and MAD are complete. So equation for this would be m naught g minus t is equal to m naught into 2A naught. I multiply this with 2 and add these two equations. 2t gets cancelled out. So 2m naught g is equal to 5m naught into A naught. M gets cancelled out. A is equal to 2g by 5. If A is 2g by 5, A naught, action of this block is 4g by 5. Alright?
Yes, sir.
Okay. I'll give you another problem. Solve it completely and let me know the answer. M naught and M naught, find the acceleration of the blocks. I'll give you 1 minute. How do we do this?
Sir,
Yeah.
G by 5. A not equal to
Acceleration.
0.
Okay, this is J by 5 and this is G by 5. Okay, tell me the equations now. If this tension is T, this is T and T, 2T, 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 4T. So force on this M naught is 4T. So I can write 4T is equal to,
Sir, is it with T into we take 40?
yeah, because see, this is T, T and T, 2T, 2T and 2T, 4T.
Okay, so 1 minute, sir. Give
See, answer
not
is not
1 minute,
important.
15
I want
seconds,
you
sir.
to understand the process. Answer could be wrong, that's okay. But your method should be correct.
Yeah, sir, I tried my best.
Okay,
It
tell me the
could be
equation for
right,
this
but
mass.
in numericals are wrong, sir.
Sorry?
Which one, sir?
2n naught.
Second one.
2n naught.
Second one, sir. M naught minus T.
M naught G minus 40.
M naught G
M
minus
naught G
T
minus
equal to
40.
M naught G minus
no,
T.
sir.
Look at the
4
FBD
M
of this one.
naught A naught.
M naught G minus
4
T,
M naught A naught.
M naught into
4
4
in
A naught. Why is it 4 A
G
naught?
minus T.
acceleration force.
Yes, acceleration is 4 A naught. So I multiply this with 4 and I add these two equations. 4T gets cancelled out. So
T
4 M naught G, yeah,
equal to 4 AM A naught.
16 plus
For
1, 17.
acceleration of 4 A naught. Yes, sir.
4G by 17. Acceleration of the lower block is
Yes, sir. 4 G by 70.
16G by 17 is the lower block. Acceleration of the lower block. Because if it's A naught, it's 4 A naught. I got A naught as 4G by 17. So it'll be 16G by 17.
I have given this question also as homework.
This one,
Yeah, sir.
okay, okay. Now let's change the problem a bit. Instead of pulleys like this, now find out acceleration of the masses. M naught and M naught. All right, I'm just taking M naught, M naught. It could be M1, M2 also. M naught, 2 M naught, 1 kg, 3 kg, 10 kg, 100 kg, anything. But I'm just taking it as M naught and M naught so that M naught gets cancelled out. That's it.
Forty.
What is 40? Acceleration.
Acceleration.
4T.
Sir.
What is T?
T2.
Okay, let me solve this. FBD of this one is, if this is T, this is 2T. So let this be T, this will be 2T. So M naught G, 2T, and this is T. T is equal to M naught into A naught. What is the acceleration of the lower block? If the acceleration of the upper block is A naught, what is the acceleration of the lower block? What is the acceleration of the lower block?
2 A naught.
If it were 2 A naught, I would have not done this problem again and again, no?
4, sir.
Yeah,
40.
sir. Do I not?
Either you use pulley method or push-pull method.
Four.
Either pulley method or push-pull method. Tell me the right answer for acceleration, students. Think and tell me, na? Push it by X. See what happens to this one.
Push-pull methods.
Okay, so push it by X. What is happening? String is stacking by
X and 0 and X.
2x. 2x
2X.
by
2x, sir.
4x.
Why 4X? Where is another pulley?
1 pulley,
2x,
sir.
sir.
2x.
2x.
2X. Now, if this is going by X, this is going by 2X. So if this is A naught, this is 2A naught.
Yes,
So if this
sir.
is A naught, this is A naught by 2.
Yes, sir.
Why do you get 2A naught then? Why are you telling 2A naught? Everyone is telling 2A naught. Why? And look at this pulley method is even simpler, no? This is A naught. This is 0. Required to find this. A naught plus 0 by 2. That's A naught by 2. Students, constraint is very important. Do you want me to do the constraints again? Be very clear and tell me very, very frankly, do you want me to do the constraints again? Without constraints, we cannot solve good problems in Newton's laws. All you have to do is revise after the class. 10 minutes revision. All right. So Gayatri is right. A naught by 2. Okay. Now what I do? I multiply this with 4. And I cross multiply 2 here. I add these two equations. So I'll get 2mg is equal to 5 m naught into A naught. M gets cancelled out. A naught is equal to 2g by 5. If this is 2g by 5, this is g by 5. Is it okay?
Yes, sir.
Hmm. Okay. Now let me change the problem a bit. We're still in only one category of problems in NLM. We still have a lot to do, but you people are not revising and you're not letting me go forward faster. ఇది 1 minute లో చేసిన ప్రాబ్లమ్స్ ని ఇంత టైం తీసుకుంటున్నాం 37 minutes తీసుకున్నాం ఇప్పుడు 20 minutes తీసుకున్నాము not complicated.
3x, 4x.
ఏంటి 4x? Why do you get 4x there? Acceleration of this is a naught. Acceleration of this is what? What is acceleration of this block?
A naught by 2.
How do you do that? Push-pull method or pulley method?
Push pull method.
All right, that's a naught by 2. You can do it with pulley method also. You'll get the same thing. This is A naught, this is 0, 0 plus A naught by 2 is this one. So A naught by 2. That's right. Yeah. Who is it? Who gave me A by 2? Answer?
Navneet.
Navneet. Yeah, that's right, Navneet. All right. Now, let this be T. Let this tension be T here. If this is T, this is 2T. So equity of the upper block on the table is T like this, M naught and M naught, or M naught and 2 M naught, let's say. Or let's say this is 2 M naught and this is M naught. All right. Please revise, students. T is equal to M naught into A naught for the upper block. Sorry, 2 M naught into A naught. For the lower block, this is how much? 2T, and this is M naught G, and acceleration is A by 2. So I'll have M naught G minus 2T is equal to M naught into A naught by 2. So I multiply this over here. I multiply this with 4. I add these two equations. 4T gets cancelled out. So 2mg is equal to 9m naught into A naught. So A naught is equal to, m gets cancelled out, 2g by 9.
Yes, sir.
A naught is 2g by 9. This is g by 9.
G by 9.
All right. Now let me complicate this a bit and then we'll go for the next problem. Now this, I'll not come back to this method again. Think about this carefully and answer the questions. If this is A naught, what is the acceleration of the lower block?
A naught by 2.
No.
1, 2, 3. A naught by 4. 4. A naught by 4, sir.
Yes, A naught by 4. Right. Now look at this. If this is T, this is 2T. If this is 2T, 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 this is 4T. So tension on the lower block is 4T. Right. So T is equal to mass into acceleration. For this one, it is mg minus 4T
It's
is equal
equal
to mass into A naught by 4. So what I do, I multiply this with 4. So
4.
this becomes 16. And this is gone. I multiply this with 16 and add these two. 16 gets cancelled
16.
out. 16t gets cancelled out. I'll have 4mg is equal to 17m into A naught.
A
So
naught.
A naught is equal to 4g by 17. So if A naught is equal to 4g by 17,
G by 17.
yes, thank you. You're right. Okay. Now one last problem, similar problem. Then we'll move on to problem with rope having a mass. Now strings are massless here. 2m0 and 3m0, or 2 kg and 3 kg, let's say. Find the acceleration of the block. Again, I just draw the
Is
FBD
it
first.
year two, sir? Second
This is 2
full.
kg, this is 2 kg, this is 3 kg. 2 kg,
Okay.
3 kg. So 2 kg block, if this tension is T, this throughout it is T, so this is T and T, this is 2T. So acceleration of the lower block, oh, sorry, just a second. 2G, this is 3G, this is 2T, and acceleration, let the acceleration of the upper block be A naught upwards. This will be something downwards. How much is it?
A naught by 2.
Yes, A naught by 2. So 2G minus T is equal to 2 into A naught. And for this one,
A naught by 2.
sorry, this is T minus 2G.
A naught by 2.
Yeah, A naught by 2, right? That's right. So this is T minus 2G, not 2G minus T. Be careful. Because I've taken acceleration in this direction. So net force should be equal to mass into acceleration. Net force will be in the direction of acceleration. T minus 2G is equal to 2 into acceleration. Here, 3G minus 2T is equal to 3 into A naught by 2. I multiply this with 2 on both the sides. I'll get 4 and this becomes 6. I multiply this with 4. I add these two equations. 40 gets cancelled out. So I get minus 2G is equal to 11 into A naught. So A naught is equal to minus 2G by 11. And this will be minus. That means the acceleration direction which I presumed is opposite to actual acceleration. So my actual acceleration is opposite to presumed acceleration. నేను presume upward చేసుకున్నాను, but particle is actually going downward. Actually accelerating downward. Minus 2G by 11 అంటే నెగిటివ్ వచ్చిందంటే. So this is 2G by 11 downwards. Acceleration of this block is
Minus G by M.
upward. G by 11 upwards. All right. Understand this problem carefully. Here, I've taken the acceleration direction to be something. The answer turned out to be negative of that one. That means my acceleration, actual acceleration of the particle is opposite to the presumed acceleration. All right. Should I give you one more or should I go ahead with next one? Should I give you one exercise? Okay, I'll give you one simple one. This mass is m naught. This mass is m naught, or this is 2m naught and that is m naught. Okay. Find the acceleration of the masses.
A naught and 3 A naught, sir.
A naught and 3 naught. Right, that's right. That's good. So constant equation is right. Relation between acceleration is perfect. But now I need to go for FBD and then F is equal to MA. FBD, how will I draw the FBD? For the upper block, with the tension with T, this is FBD. For the lower block, this is, if this is T, T and T. So this is T. Sorry, if this is T, look at this, students. Is it T prime, T prime, T prime, and T prime will be T by 3. Or if I say this is T, this whole string is T, tension the whole string is T, T plus T plus T is 3T. So this will be 3T. ఇది T అనుకుంటే ఇది 3T ఉంటుంది. ఇది T అనుకుంటే ఇది T by 3 ఉంటుంది అంతే. Because T by 3 is difficult to handle. Little difficult to handle. Handle అంటే difficult to cross multiply. You will have to cross multiply and everything. That's why considering this to be T and this to be 3T. So 3T is equal to 2m naught into a naught. For this particle, m naught g minus t is equal to m naught into 3a naught. So I multiply this with 3. I add these two equations. 3t gets cancelled out. 3m naught g is equal to 9 plus 2, 11. 11 m naught into a naught. M naught gets cancelled out. A naught is equal to 3g by 11. If this is 3g by 11, this is 9g by 11. Is it clear, students? Achha, దీని మీద normal reaction ఉంటుంది కదా. Why am I not considering normal reaction at all? I'm not talking about normal reaction at all. Why? And I'm not talking about Mg here. You'll have normal reaction like this. You'll have 2 Mg like this. But I'm not considering these two forces. Why? Because there is no motion vertically. For this one, there is only motion horizontally. For this, there is no motion horizontally, there is only motion vertically. So all the vertical forces equal to mass into acceleration rasanu. All the horizontal forces equal to mass into acceleration rasanu. Vertical forces ఏమవుతుంది? N minus 2mg is equal to 0. So N is equal to 2mg. Now do this one. M naught and 2m naught. I have to find the acceleration of the blocks. It's an old problem or a new problem? Like we have all the problems we are doing, are they of any new problem? You identify them as old problem or a new problem? Is this an old problem or a new problem?
Old.
Old one.
Old one, sir.
Okay. Why is it old one? Yeah, that's the whole problem. You're right. All fall into the same category. Just configuration vary అవుతుంది, but method is same. And the constant equations are similar. Push pull method తో వచ్చేస్తుంది, or pulley method తో వచ్చేస్తుంది. Right? We still didn't enter into a new problem. All right. So if this acceleration of this block m naught is a naught, what is the acceleration of this block?
3 అనొచ్చు.
Okay, 3a naught. How do you get 3a naught? What is the procedure you have adopted to get the answer 3a naught?
Here, string is flattened by x and x from the starting.
Yes.
M naught.
Okay, so if this is a naught, this is 3a naught.
Yeah, sure.
Okay, I'll prove it to you. 3a naught. Let's prove 3a naught. This is a naught. This is 0. A naught plus 0 by 2. So this is a naught by 2. If this is a naught by 2, this is 0. A naught by 2 plus 0 by 2, which is a naught by 4. So I'm getting a naught by 4. I'm not getting 3a naught. What wrong am I doing? What wrong did I do? I got a wrong answer. It's a naught by 4. My answer is not 3a naught. Why?
Sorry, sir. I've taken the direction wrong, sir.
A direction wrong.
ఇక్కడ పైన ఏం నోట్ దగ్గర మీరు రైట్ సైడ్ తీసుకున్నారు కదా సార్, నేను లెఫ్ట్ సైడ్ తీసుకుని ఆ పులిని స్లాకెన్ చేసి ఇక్కడ ఎక్స్ ఇక్కడ కింద ఎక్స్ తీసుకున్నాం.
Okay, stack and push pull method చేసావా?
యా సార్.
Okay, even if
Sorry,
I do
sir.
that, I push it by x. String stacking is by x and x, 2x. This 2x comes here. This pulley moves by 2x. String stack is by 2x and 2x, 4x. So if this is a naught,
4x.
this is 4a naught. If this is a naught, that is a
Yes,
naught
sir.
by 4. But you will not get 3a naught. Okay, now let's draw the FBD of the particles. For this block, let the tension be T. If this is T, T, this is 2T. If this is 2T, 2T and 2T, 4T. So
40.
right. So this is T for M naught. 40,
For 2.
2 mg downwards, 2 mg component along the incline is 2 mg sine theta, which is m naught g. If this is a naught, this is 4a naught. I'll write the equation for this upper block. T is equal to mass into 4a naught. For the lower block, m naught g minus
A naught.
minus 4t is equal to m naught into a naught. 2m naught into a naught, because mass is 2m. I multiply this with 4. Add these two equations. 4t gets cancelled out. M naught g is equal to 4 plus 16. 4, 4, 16. 16 plus 2 is 18 m naught
Yeah.
a naught.
M naught.
M naught gets cancelled out. A naught is equal to g by 18.
Yeah.
A naught is g by 18. So this will be
4G
4g by 18.
by
4G.
So that is
8.
2g by 9.
Yes, sir.
yes, sir.
So one acceleration is g by 18, the other is 2g by 9. Okay.
Okay.
Okay, now look at this, students. I've got a rope of linear mass density as lambda naught. So lambda naught is equal to mass by unit length. Mass per unit length is lambda naught. This is small lambda, Greek lambda, and this is capital lambda. I'm using capital lambda. So lambda is m by L. Mass per unit length is lambda. All right. Linear mass density. That's called linear mass density. All right, students. We'll continue with these problems tomorrow. So you have got chemistry class now. Join the next link. And please, students, do the 10 minutes exercise today. And tomorrow is going to be really, really tough in thinking because we're going to enter into new models, new kinds of problems. So please come prepared mentally, and also do the 10 minutes exercise and come back, please. Thank you all, students. Have a great day. Thank you, ma'am. All right, students, you can leave the session and join the next link.
Bye, sir.
Yeah, bye bye.